maximum or minimum displacement. Let's say I'm throwing a ball vertically upwards. A ball vertically upwards. So this is the initial position of the ball. It's in my hand. There's no velocity. I'm throwing it with a particular velocity. Let's say 10 meter per second. Right? That's the initial velocity of the ball. I'm throwing it vertically upwards. So when the ball reaches the maximum height, what will be the velocity of the ball? Because of gravity, the speed of the ball would decrease. 10 meter per second, 9 meter per second, 8 meter per second. So at some point, when it reaches the maximum height, ball would stop for a moment. For a moment, the velocity will be 0 meter per second. Then it would come back down. It would gradually increases the speed with an acceleration equal to g. It would gain speed. So that's the motion of a ball thrown vertically upwards. I'm going to plot this motion on a graph, on a position time graph. Position on y-axis, time on x-axis. You'll get something like this. A curve. What's the slope at this point? At the topmost point. And what's the slope here? It's a positive slope, right? What's the slope here? It's a negative slope. What's the slope at the topmost point? Slope equals 0. Slope equals 0. What is the slope of a position time graph? Slope of a position time graph is the velocity. Or in short, at this point, velocity is equal to 0. So velocity of an object is 0 when it reaches the maximum displacement. Let's solve a problem. Position function is defined as minus 5t square plus 2t. What is the minimum displacement? What is the minimum displacement of this object? Okay. There are 3 steps you have to follow to find the minimum displacement or maximum displacement. First step is find the derivative of position function to find velocity function. So v of t equals dx by dt. So d by dt of minus 5t square plus 2t. If you solve it, you'll get minus 5 into 2 minus 10t plus 2. The second step is equate velocity function to 0 and solve for time t. That's the second step. So that's my velocity function, minus 10t plus 2. I'm going to equate it to 0. Minus 10t equals minus 2. T equals 2 by 10. 0.2 seconds. That means when time t equals 0.2 seconds, the object would reach the minimum or maximum displacement. In this case, maximum displacement. How do we find the maximum displacement? This is the time, right? And we're going to find the maximum displacement. So the last step is substitute t, the value of t, in the position function, back in the position function. This is our position function. I'm going to take t equals 0.2, we put it back here. So x of 0.2 equals minus 5 times 0.2 square plus 2 times 0.2. 0.2 meters. 0.2 meters is the maximum displacement of this object. Let's do another one. Omar is a marine biologist scuba diving from a boat. He dove down to the lowest point to pick up a sample from the sea. Omar's dive can be described mathematically by the position function y of t equals 15t square minus 4t. Omar's minimum displacement is, so we have the position function y of t equals 15t square minus 4t. First step is to find the velocity function, dy by dt. So d by dt of 15t square minus 4t. Differentiate each term. The first term, 15 times 2, 30t minus 4. So this is my velocity function v of t. At maximum displacement or minimum displacement, velocity is 0. So I'm going to equate this velocity function to 0. 30t minus 4 equals 0. I'm going to solve for t. So 30t equals 4. T equals 4 by 30 seconds. In the last step, I'm going to take this value of time, I'm going to put it back in the position function. So y of 4 by 30 equals 15 times 4 by 30, the whole square, minus 4 times 4 by 30, minus 0.28 meters. That's the minimum displacement of Omar.